We've all heard claims by battery manufacturers how their battery is longer lasting than the other guys. So it got me thinking, how can I compare two brands quickly? First thing I noticed was this blue one is lighter than this golden one. I put it on a scale to verify it, and because it got me thinking about, say, energy density, but my measurements were 131 grams, and on this one 138 grams. Close enough. So it got me thinking about energy density, that maybe the metals inside, there's heavier metals and more metals, and this might be better or longer lasting, whereas the other one is lighter, and maybe they are cheaping out on some materials inside. But it doesn't quite work that way, because batteries are made of alkaline metals and alkaline earth metals, and what that means is they have some of the alkaline metals have lithium in it, and lithium is a metal that floats on water. So if it's lighter than water, heavier doesn't necessarily mean better or longer lasting. So okay, that one was off the table. The next thing I measured, okay, let's check out the voltage. Here is my handy voltmeter, and let me just dissipate the charges of it so it gets back to zero. There. And if I measure the voltage on one, alright, I'll switch it around. And there, 1.48 volts. And on the other, it is 1.55 volts. But voltage is not really conclusive, because the voltage level drops. Say on a digital camera, they work on 1.5 and 1.4, maybe 1.3, but they don't work on a 1.2 volt level. On a, in a flashlight, you might be able to run or an LED light bulb or a conventional light bulb on 0.9 volts, but that's it. Basically, a 1 volt battery was designed to be 1.5, and it's down to 1 volt, is basically dead, and you can't get anything out of it. That's just the nature of things. But the idea of voltage is connected to the metals that are inside a battery. Two dissimilar metals will provide the voltage or generate the voltage in a battery, and the voltaic potential or galvanic potential of metals that are teamed up inside a battery is fixed. So, and manufacturers are fixed. This has to be a 1.5 volt battery. It can't be a 6 volt battery by changing it to different metals. The idea of voltage is that some metals have their electrons easier to dislodge and move around than some other metals. Some others cling to their electrons with a little more force. Some good conductors electrons can be ripped off with a lot less force. So, but the idea of voltage is fixed. So is the size. It has to have this dimple on it. It has to have this diameter, so it fits into devices, battery compartments. So manufacturers don't have a lot of wiggle room. It has to be a 1.5 volt battery. They have to have metals that are teamed up to provide between the two of them a 1.5 voltage, and that's that. So what can I do to check if one of them is longer lasting than the other? If I switch to amps on the other one and switch this one over to the amps, so my next thought was, okay, let's measure amps on these ones. Now, amp measurement will short circuit the battery, and it's important that I use these needle points that are really that have really small surface area. I don't know, there, and I'm only using the tips of them. If you use a thick wire with a huge contact area on it, it's gonna flatten the battery in no time. So milliamps wise, what I found is that this battery has there 48 milliamps, and the other one has a lot more, about 60, we'll call it 60. So 48 versus 60. Now that's a significant difference. Say 60 over 48 there, so that's 25% better. Sorry, there's the number. 25. The blue is 25% higher amperage than the gold one, with practically the same level of voltage. Practically, the idea of amperage means that when you measure amperage, you measure number of electrons going through a conductor. It's a head count of an actual number of electrons. Now those number of electrons go in, or are measured in, packages called coulombs. So but the idea still is a head count for measuring amperage, number of electrons going through a conductor. So that's why you don't want a thick conductor, you don't want a whole lot of electrons trading places inside the battery, because it's just gonna go flat. But using the same device, 60 milliamps versus 48 milliamps, that's a significant enough difference. So what I concluded and measured is that this one discharges a higher number of electrons than this one. If it discharges a higher number of electrons, it's probably gonna last longer. Not only it's gonna flatten faster, or discharge itself faster, but it's put in an electrical device, it's probably gonna power a small motor longer. All I need to do now is connect it to a motor, not a light bulb, because light bulbs can have different light output. You need to measure whether the light bulb is producing more heat and more light, say by 5% or 20%, and that's really hard to measure if one light bulb is brighter than the other light bulb. So put it in a motor and make it run at whatever RPM a motor is running, and see how long it lasts. I don't have a motor. Everything I have is starter motors and big things. I don't have small stuff, but if you try it out and let me know, that would be nice.